Yeah, this is the second video for a hyperbola, which is the last of the conic sections we'll be talking about. There's another problem here where again we're given all our equation of a hyperbola in the form that we don't like, which doesn't have all the information readily available to us. So we need to manipulate it by completing a square. And this one's a little more involved because we have to actually really complete the square for both variables. Luckily they are kind of like set up in the way we want. So I'm going to right away factor the 9 out of the x terms. So that'd be 9 times x squared plus 8x. I'm going to leave a little space and factor the negative 4 out of the y terms. So negative 4 times y squared plus 4y. Leave some space, and that's going to equal negative 92. I move the 92 over right away. Alright, what goes in here, we have to add 16. When we add 16 inside that parentheses, everything is being multiplied by 9. So really we just added 144, which is 9 times 16 to the left side of the equation. So I've got to do that for the right side also. Okay, in the parentheses here, we'd have to add 4 to complete that square, which we multiply by negative 4, which is negative 16. So we really subtracted 16 from the left side. So we got to do that from the right side also. Okay, so now we can clean this up a bit. So this is 9 times x plus 4 quantity squared minus 4 times y plus 2 quantity squared. And this equals something. I have no idea what this is. That's 108 minus 144. 144 minus 108, which is 36. I think it's 36. That's convenient. It's 36. Okay, if we divide everything by 36 to get it to equal 1 on the right side, we will have this. We'll have x plus 4 quantity squared divided by 4 minus y plus 2 quantity squared divided by 9 equals 1. Alright, let's pull the information off this. The center, easy to find from our standard conic form, is h and k. So in this case it's negative, I meant to do that in green, I'm sorry. That is in this case negative 4, negative 2. Okay, so that's the center. We need to find the vertices. Okay, the vertices, I can tell you right away that this is going to be a left and right parabola, right? Because the x term is positive. Sorry, a left and right hyperbola. The x term is positive, so that means that this a is going to be how far away we are from our center. So that means it'd be h plus or minus a, comma k. So in our case, it's negative 4 plus 2, right? Because a squared is 4, so a is 2. So we'd be at negative 4 plus 2, which is negative 2, comma negative 2. And negative 4 minus 2, which is negative 6, comma negative 2. So those would be the vertices. And then because the transverse axis is horizontal on this one, the foci, this looks like a U, it's bothering me. Foci would be similar, but we'd go C in either direction. The thing is, I don't know C yet, so let's figure that out. Okay, so figure out what C is. So we know that C squared is equal to A squared plus B squared for a hyperbola. And so for our hyperbola, C squared is equal to 4 plus 9. So C squared is equal to 13. So C is just the square root of 13. The square root of 13, so square root of 9 is 3. The square root of 16 is 4. So it's somewhere between 3 and 4. Let's just call it 3.5. And it's not, but it's close enough. So it's about 3.5 away for when we graph it. But since we can just write this precisely for our actual coordinate point, why not do that? It's just negative 2. I'm sorry, it's not negative 2, it's negative 4, which was h. Is negative 4 plus root 13, comma k. No, not comma k. I know what k is. It's negative 2. And it's negative 4 minus root 13, comma negative 2. Okay, so we can put all this information on here now. Or we can come up with we can do the equations too. So equations of asymptotes. Okay, I don't know where the squiggly lines on everything I write, but whatever. that's just going to be the y. Okay, so it's y plus 2 from our equation equals plus or minus b over a. So b was b would be 3 and a would be 2, so plus or minus 3/2 times x plus 4. Okay, like literally I took the y plus 2 and put it right there. I took the x plus 4 and put it right there, and then this is just b over a. That's it. So now we can put all this stuff on here. The center was at -4, -2. Okay, the vertices were at -2, -2, and -6, -2. The foci are at, like we said, root 13 was like 3.5. So -4 plus 3.5 is somewhere like right here. Okay, and then it'd be somewhere right here on the other side. Okay, we can draw in. Oh, we also know b was 2. No, b was 3. So if we go 3 up and 3 down from our center, we'll have the endpoints of our conjugate axis, which can help us draw in this box, which we call a hyperbola box. And then the diagonals of this hyperbola box, which correspond to the equations of the asymptotes that we already found. That looks like a pretty squiggly line to me. Should be straight. We have that, and then since it's side to side, it opens and does this. And it doesn't quite touch these asymptotes, but it's hard for me to draw that. So something that would be good would be to label these foci. This was the one that was -4 plus root 13, comma -2, and this is the one that is -4 minus root 13. Sorry, -4 minus root 13, comma -2. And then that's it. We did it. Okay, so another kind of problem. In this one here, we're given information about the hyperbola. So let's just put that information on the graph real quick. 7, 5. This is 7 and 5 right here. That's one vertex. 7 and -1. That's the other. Wait, 7, -1. I screwed that up. Sorry. 7, -1. That's the other vertex right here. So if these are the vertices, that means the transverse axis is vertical, which means this is going to be an up and down hyperbola. Okay, the foci are at 7, 7, which are, that's 7, 7, and 7, -3, which is right here. Okay, so that means the center is going to be right between the foci and right between the vertices. So this is right between. So the center is going to be right there. And that point, HK, the center, is at 7, 2. Okay, so boom, there's HK right away. We've also been given the distance, well, not explicitly, but we can determine the distance from the center to a vertex. In this case, this is B. B is 3. And we've also been given, not explicitly again, but we can determine from the center to a focus, that distance right there is 1, 2, 3, 4, is 5, right? So C is 5. So we go back and we look at our equation for a hyperbola, and since this is up and down, the y term is going to be positive. Y minus k quantity squared divided by b squared minus x minus h quantity squared divided by a squared equals 1. So that's our equation we're working with here. And what do we have? Well, we have hk, so we have this, and we have b, and we just need a. So we have a way to find a, because a squared, nope, it's not, sorry, c squared is equal to a squared plus b squared, and we just want to know b squared, so that means b squared is equal to a squared minus c squared. Is it? Yeah. No? Wait, what? I did that backwards, sorry. C squared minus a squared. I can do math. Okay. So b squared is going to be equal, and we have c squared is 5, so 25 minus a squared wait, we don't have, we're trying to find a, we already have b. I just did it wrong, totally wrong. I mean, not really, the number is still the same. So a squared is equal to c squared minus b squared. Okay, so a squared, we have c, it's 5, so that'd be 25. C, 5 squared is 25. Minus b squared, b is 3, so minus 9. That means a squared is equal to 16, or a is equal to 4. I don't really care what a is, because I want a squared. I just want to write the equation. I have everything now, so I can do that. The answer is going to be y minus k. K was 2. Quantity squared divided by b squared, which was, b was 3, so that's 9, minus x minus h was 7, quantity squared divided by a squared, which we just said was 16, and I started writing 25, 16, and that equals 1, and that's it. There's your equation of your hyperbola that has that stuff. We got one more problem. Okay, so this is a similar problem here where we're given information about the hyperbola and we want to come up with the equation. So first of all, let's put the equation on the graph, or put the information on the graph. 0 and plus or minus root 3 are our vertices. So root 3 is like 1.7, so they'd be like right there. The conjugate axis is 4. Well, there's two different axes in a hyperbola. One is the transverse axis. That's the one that has the vertices and the foci on it. And then the other one is the conjugate axis, which is the other one. And so when we're given the conjugate axis, like if the up and down axis is the transverse axis, the left and right axis is the conjugate axis, and it has a length of 4, which means if we go 2 over and 2 to the side, that would be our conjugate axis right there. You can go even farther and draw in our little box if we wanted to. We don't have to do this because it's not asking for the sketch, it's just asking for the equation. But then our asymptotes would do this, okay. And then we know this, that's a really bad drawing, but the center would be right there. So the center of this is 0, 0. So center HK for this, HK is just 0, 0. That's nice. We're already given b. Okay, b is this distance. B is root 3. So b is root 3. That means b squared is 3. We've actually also been given a. A is this distance. It's 2, right? So a equals 2. So a squared would be 4. And if I have h and k and a and b, or a squared and b squared, then I'm done. I have everything I need. This is just going to be x squared because it's x minus 0, quantity squared, so just x squared, right? H here. So let's just do that. X minus h, quantity squared. Oh, let me erase all this because this is also an up and down parabola because the vertices are these red dots. So this is going to do this. Okay. If it's an up and down parabola, that means that the y term is positive. So if we write it, we're going to end up with this: y minus k quantity squared divided by b squared minus x minus h quantity squared divided by a squared equals 1. And so, like, we have all these terms. HK, this is 0, this is 0, b squared is 9, and a squared is 4. So let's just write this all out. It's going to be y squared divided by 9 minus x squared divided by 4 equals 1. And that's it. That is the equation of that hyperbola right there. And that's really all there is to it. If you have any questions that you can think of, just leave a question in the comment and I'll try to get to them as soon as I can. But thank you very much for watching the video.